The first thing that comes to mind when we think of night vision is a spy in an action movie looking for an enemy with a moonless night. What most of us have wondered is whether those gadgets really work. Surprisingly enough, the answer is yes. In fact, with most night vision goggles, it is possible to see as far as 200 yards in a really dark environment. There are two different technologies that make night vision possible: image enhancement and thermal imaging. Image enhancement works by collecting even the smallest amount of light present but imperceptible to our eyes and amplifying it to the point that we can easily observe the image. On the contrary, thermal imaging works by capturing the upper portion of the infrared light spectrum, which is emitted as heat by objects and living beings instead of being reflected as light. Going deeper into thermal imaging, we see that it's made up by 5 consecutive steps. The final product is an image colored with colors that range from blue to red depending on the intensity of the infrared emission and, as a consequence, on the temperature of the object displayed. Initially, a special lens focuses the infrared light emitted by all objects in view. Then a thermogram, a detailed temperature pattern, is created by an array of infrared detector elements. Shortly after, the thermogram is translated into electrical impulses, which will be processed by a circuit board and displayed on an external screen. Image enhancement, however, is what most people think of when we talk about night vision. This technique relies on a special tube called image intensifier tube to operate. A conventional lens, called the objective lens, captures ambient light and some near-infrared light, the light we are not able to see, and sends it to the image intensifier tube. In the tube is present a photocathode, which is used to convert the energy of the light's photons into electrons. As the electrons pass through the tube, the microchannel plate, a tiny glass disc with millions of microscopic holes, multiply the original number of electrons by a factor of thousands. At the end of the image intensifier tube, the electrons hit a phosphor-coated screen and create the greenish image we all know. Would you like to see your topic discussed on a future video? Just write it down on the comment section and don't forget to subscribe to this channel for more exciting content.